We now move into the kind of outer edge of statistics. We take a little glimpse of it. So we're going to talk about hypothesis testing. So let's say there's a claim. It's made by some big chocolate company. And it says, our chocolate bars have a mean weight of 53 grams with a standard deviation of 7 grams. So we do an experiment, and we buy a chocolate bar, and it weighs 52 grams, and we are shocked. What? So what do we think? So they said it was 53, but we said 52. But ours was 52. So what we think is that they said the mean was 53. So this is our mean over here. And this is our experiment. And so we think that the mean is something less than 53. We don't know what it is, but we think it's less than 53. And so the question is, can we mathematically show or demonstrate that the mean is in fact less than 53? Okay. So we're going to have some terminology here before we go any further. So we're going to have something called the significance. And the symbol for significance is an alpha. It's kind of like that. It's like a fishy. And it represents the probability that our conclusion is going to be incorrect. So we're going to say that the company is lying or not. And significance is the probability that when we make that claim, lying or not lying, there's about a 10%, there's about an alpha probability that we are incorrect. So for example, if we say that the alpha is 10%, we are saying that there is a 10% chance that our conclusion, which is lying or not lying, is incorrect. Confidence is the opposite of significance. There's not really a symbol for confidence, but the formula is 1 minus alpha. And confidence is, of course, the probability that you are correct. So if if the significance was 10%, then our confidence would be 90%. Now, it's important to point out that alpha is not a calculated value. It's going to be given to you. So I'm going to say with a significance of this or with a confidence of this. So for this upcoming example, we're going to say that alpha is 10%. So we're going to say, is the company lying? And we have to be sure with a confidence of 90% or a significance of 10%. So mathematically, what are we going to do? So the mathematical idea is we have our mean. So the mean is the claim by the company. So this is the claim. So the company makes a mean of a claim. In this case, the company said that the mean was 52. Then what we're going to do is we're going to do an experiment, and we're going to calculate the probability that if the company was saying the truth, the probability of getting the experimental result or further away from the mean, I mean. So for example, if our experimental value was below the mean, we would calculate the probability of being in this red zone over here. If our experimental value was more than mean, we'd calculate the probability of being in that zone over there. So let's actually do it. So we want to know the probability that x is less than 52. Because, right, if we go back to this one, right, the mean was 53. The mean was 53, and our experiment was 52. So we want the probability of 52 or less. So technically it would be less than or equal to 52, but since it's continuous, it doesn't really matter. So then we're going to have to find a z-score calculation. So that's going to be 52. And what's our mean? Our mean is going to be 53 divided by 7, which is going to be negative 0.14. It's going to be 1 over 7, but negative. So this is going to be equal to the probability that z is less than negative 0.14. And we're going to grab our handy dandy z-score chart. And negative 1401234 is 44.43. And that's going to be 44.43%. So the probability of it being in that zone, so let's draw a little picture here. So So our mean is 53. Our experiment said we got 52. And the probability of it being, let's use my dull red for this. The probability of it being in this zone over here is 44.43%. So, what we're going to do is we're going to say, and remember I said that for this example, we're going to have to throw it out somewhere else. The alpha in this case is 10%, which means that the confidence is 90%. So what we're going to do here is we're going to say if, in order to reject the claim, we're going to say that this probability has to be less than the significance. So we're seeing how unusual is this thing. So if the company was saying the truth that the mean is 53, then there's a 44.43% chance that we could have had this result of an experimental bar being 52 or smaller, which is not very unusual. So this is not less than that. So now we're at our conclusions. What we say is, therefore, since 44.43% is not less than the alpha, and what that means is we're not saying that the company is telling the truth, but we cannot reject the claim. We cannot reject the claim with a confidence of 90%. So what we're saying is that maybe they're right, maybe they're wrong, but we don't have enough evidence to be 90% sure that they are wrong. We'll do a couple more examples of that. A little bit more terminology before we move on. We're going to have something called the H0, which is going to be the null hypothesis. And that's the default hypothesis. That's the claim. And we accept the claim unless we have good evidence otherwise. It's pronounced H0. I think naught is like British for zero. H is the alternative hypothesis. So for what we had over here, the original claim was that the mean was 53. And what we suspected was that it was something less than 53. We never make a claim as to what the mean is. We just say whether we think it's higher or lower than the null hypothesis.